Good morning everyone. In the last class we have seen about imbibition and diffusion. I hope you might have opened your books and studied in the weekend. Let me ask you a few questions and you try to answer me whatever things that you have studied at your home. First give me an example and a definition for solute. What is a solute? NaOH is a solute. Okay, let's consider that any chemical compound that is mixed up with a solvent is a solute. So the definition goes on like this: a substance that is dissolved in a solvent is a solute. For example, let's take a chemical compound, a salt or a sucrose, something that you have in your hand that is dissolved in water or any other solvent material is the solute. And then what is a solvent? A solvent is the liquid which dissolves the solute. So solvent and solute, when they join together, they form a solution. So it's the dissolved form of a solute in a solvent. Let's also see the examples. The example, if you mix up 2 teaspoons of salt onto a glass of water, it becomes a solution. And this is what we have in the last class. Have you ever been for a party or for a room which is crowded too much? You might have been. What do you feel then? What do you feel? When you enter into a room which is much crowded with people, what do you feel? Guilty. What sin you have committed for having guiltiness? What do you used to have? You used to have suffocation, isn't it? You cannot have an easy breathing experience there in a crowded room. Why? What happens there? If it is a closed room, many would be there and they would be releasing carbon dioxide. Carbon dioxide concentration is rich in the air and oxygen reduces. So it's a process of diffusion that we have studied in the last class. See, the air that spreads onto the room, they mixes up with the atmospheric air in the classroom or in the room that you are in, which makes it possible for you to have more amount of carbon dioxide and less amount of oxygen, which reduces the capacity for you to transport the oxygen to the blood. So at once you have a suffocation, what do you do then? When you have a suffocation, what would you do? You move out, and that is the right answer. You move out of that room. Why? You are in search of oxygen. It's because diffusion happens only from high concentration to the low concentration of the solute, which we have seen in the last class itself. See, inside the room which is crowded with too much of people, you feel that atmospheric air is not much with oxygen. It's not with adequate amount of oxygen, so you feel suffocation. But when you go out in the atmosphere, you have 21% of oxygen, which gives you enough oxygen to breathe, and that is the greatest experience you have, so you move out. So in the simple process of moving out of a crowded room, you have the diffusion process. And then I'm asking you a small question. How can you stop a thief or a bad guy entering into your home? What do you do? At nights, what do you do? Do you lock the door or not? You lock the door. Why? Why can't you open the door and just to sleep inside? Oh, you are not providing an easy way for the bad guy. Bad guy may come, but he should not enter into your house in an easy way, isn't it? So, if at all he is interested in entering into your home because of you having more amount of jewels and liquid cash at your home, what he used to do? He or she has to break open your home, make a hole that is enough for him to enter, and then they enter. They take hold of everything, move out of your home, isn't it? Usually they open the door and move out. Okay? You understand what I am telling you? And this is what is happening in our system too. And whatever that is happening in the society, in our social life, it's also happening inside the biological system. And if you look at the cell membranes, they are like a lock and key. They have openings sometimes. They used to close the openings too. And if you look at the cell membrane, they are not made up of a single substance, as that we have seen in case of cell wall. Cell membranes are made up of phosphatidylipids, and not only that, they have intrinsic and extrinsic proteins. And the intrinsic proteins are the gateways for the components to enter into the cell, and they open up only at times when there is a need. If there is no need, they never open. And if you take the cell wall is a uniform structure which is made up of cellulose. And cellulose is a component which is a polymerized substance too. It contains many pores in itself. The pits, sometimes they are very defined pits like bordered pits, and some of the pits are simple pits too. They have openings. And these openings, they never have door like structures. For example, we have a very small door. And if somebody is interested in taking a big piece of rock inside this room, they could not. Even if they are interested in taking a big table inside this room, they could not. Why? The door is very much limited. So the size of the door determines the extent of the material that could be taken inside the room. Okay, you understand what I am telling you. And in the same way, the cell wall is a structure which is containing so much of pits in itself. And the pits, they have a specific pore size, and they let the molecules within the pore size to enter. And if some molecule enters with a very big size, they may tear open so that they always restrict the entry of these molecules. But in case of the cell membrane, that is plasma membrane, they selectively make it possible the compounds to enter. So only they give a way for the molecules if they ought to enter into it. If they are not needed inside the cell, they won't take them inside. But in case of a cell wall is a semi-permeable membrane, not a selectively permeable membrane, as though we have seen in case of this cell membrane. So this cell wall, they let open every molecule to enter. The only limiting surface here, or the only limiting criteria here, is the molecular weight of the substance. If it's a big substance, they cannot enter. If it is a small substance, they could enter. And this is the typical structure of a cell membrane. Look at it. And here these are the extrinsic proteins, and these are the intrinsic proteins. And these intrinsic proteins, they have a very super great ways, and they get open only if they are taken by the transit proteins. So we have so much other proteins here. Some proteins are receptor proteins. They sense the material which is to be taken inside. And some other proteins which are present here are transit proteins, and these transit proteins, they take the material from the outside, they travel for some distance, and they make it possible to enter through this intrinsic protein and move to the other side of this membrane. Okay, and this is the usual work that is happening inside these cell membranes. As I have told you, this is made up of a phospholipid bilayer. And this is the phospholipid bilayer. Here in the blue color as well as in the yellow color markings you might have seen. And this is the phospholipid bilayer, and they are embedded with so much of proteins, as I have told you. And they also have some carbohydrate chains. Why it is for? It's for the identification of the compound. Somebody should identify, isn't it? Somebody is just pressing the calling bell of your home. What would you do then? What would you do if somebody is pressing the calling bell of your home? You open the door and ask them to come inside, whoever it is. Do you do that? After you looking at them, whoever it may be, whether they are known to you or not, will you ask them to come inside? No. You first look at them, isn't it? You look at them. If you know them already, you let them inside. If they are not known to you, if they are a stranger, then you ask them who you are and why you are here, isn't it? At the same way, this membrane is also doing. And these carbohydrate chains which are present there, these are the carbohydrate chains, and they just ask the material who is interested in coming inside, just verifying it whether they should be taken inside or not, if there is a dire need inside the cell or not, and then they take the material inside the cell. This much of detailed process is happening in the cell membrane, whereas in case of a cell wall is a dead substance, it's a dead material, and it never cooperates with these type of activities because it's not actively transporting anything. They just let the molecules inside on the basis of the molecular weight. As though I have told you, this door is very small, so a big table cannot be taken inside. The molecules which are bigger in size cannot be traveled in case of a cell wall. And if you look at this, look at the two pictures, what is the difference between them? This is a morning time and you are looking brisk, you are looking smart, and at the afternoon, exactly at 1 o'clock, how would you look like? You feel very tired, hearing all the boring lectures. You may not be good at most of the time. You are thinking that I have to move soon. You may be having some other works and somebody is demanding outside and you have to leave out for sure. Such things would happen, isn't it? And see, this plant is very brisk and this one is not brisk. Look at the leaves. They are not up straight. They are flowy down. Why? What happens? Adequate amount of water is not available to these plants. This is rainy season. You might have seen all the plants coming up. Very good. The growth of the plants remains very good in this entire month. But when you look at the plants at the summer season, at the noon time, they may not be very good. They show a face as if they are having so much struggles in their life. Why? What happens? They don't have adequate amount of water. When water comes inside the plant cells, they makes them brisk. The cells become turgid, and so it is possible for them to pose a very good look. But when you look at the plants which are not with water, they are not good. They are not looking good. Sometimes they become flowy, they die because of the non-availability of water. And there, if you look at it, osmosis plays an important role. For the entry of water, in the last class we have studied that diffusion is important. But when you look at it, osmosis is also equally important for the plants to transport water within their system. From the root to the stem and from the stem to the leaves, it's very much important for us. In the last class, we have studied about diffusion pressure deficit. I was telling you about the diffusion pressure that operates whenever a diffusion happens inside the system. And time goes by, the diffusion reduces. It's because of a deficit in the diffusion pressure. When a diffusion pressure deficit happens, then the next slot is for the osmosis. It's because an osmosis happens when there is so much of solvent present inside the system. That is what we are trying to tell. And you take two test tubes here, and in one test tube you are filling it with the distilled water, and in the second test tube you are having a concentrated salt solution. Let's take it as a saturated salt solution. I have already explained to you about the preparation of a saturated salt solution, isn't it? Take a test tube, put as much salt as you can, just mix it up. If it mixes it up, put more salt into it and try to mix up. At one point, no other amount of salt can be mixed up. It remains as the concentrated solution, and that is the utmost concentrated that it can reach. It is the saturated solution that you can prepare. You prepare a saturated solution, pour it into a test tube, and you already have a test tube which is with the distilled water. And you take a semi-permeable membrane. I have to tell you about the semi-permeable membrane. What is a semi-permeable membrane? You all have semi-permeable membrane. You take your cloths are semi-permeable membrane. We all have semi-permeable membrane in our body system. Semi-permeable membrane is a part and parcel of our life. A membrane that is having too much of pores in different sizes, and that is a semi-permeable membrane. Usually we have in our kidney all the other organs that are operating with us. And if you look at the semi-permeable membrane, they have numerous pores, but the pore size may be very much limited. Maybe it is in micron size, 10 to the power of minus 6 meter size. Okay, and the sizes may not be very big. If it is very big, maybe for example you take some water and you pour the water onto a cloth. You take a cotton cloth, pour the water onto the cotton cloth. What happens then? The dust and the debris that are present on the water, they just remain above the cloth, and the water, they moves down, isn't it? This quite often happens. Some of you, when you are taking water from the tap, you used to cover the mouth of the vessels with a clean cloth, isn't it? To just avoid the dust and other particles that are coming with the tap water or with the municipality water. So what you actually do here is you are filtering it out. The same thing happens here. When you take a semi-permeable membrane, they filter the molecules. Usually water is a very light molecule and it can move apart. So you are having a distilled water test tube and you are also having a saturated salt solution test tube, and both of them you are taking a semi-permeable membrane, adding some dilute salt solution into it and placing it inside the test tube. And what happens at some point of time? You are leaving it aside and moving out, and after some time you are entering into the room. What would happen inside these two things? What will be the result? Can you please guess? Which bag? This one, first one, or the second bag? Second one. Usually the bag in the second one, they become very thin because the water molecules that are present inside, they move out. Why? We will be studying about it. And in the first bag, they become very big. They enlarge in size because the water molecules from outside, they enter into the inside of the bag. And why this is happening, how this is happening is what we are just trying to tell about. We shall do this experiment in the classroom, not now, in some other day. And this is the explanation of what is happening here. See, this is the pure water. At first, in the first tube, I was telling you that there was a pure water inside it. And it is a distilled water. It doesn't have any amount of mineral salts inside it. No salt concentration is there. So we have placed the water molecules alone here. And if you see here, this is a sugar solution or a salt solution which is also having the salt or sugar molecules embedded in it. So what happens here, you just look at it, this is a pure water, this is a sugar solution. And believe me, now I am telling you about the osmosis. In osmosis, solvent alone moves, not the solute. But in the last class I was telling you about the diffusion. In diffusion, solute alone moves and not the solvent. Everything is determined on the basis of concentration. The last but one class we have seen in detail about the concentration of the solvent, solute as well as the solutions. How they are formed, molarity, molality, normality and all we have discussed about it. Okay, and now coming to this point, if you look at it, this is somewhere having a concentration of a solute molecule and this is having a nil concentration of the solute molecule. No concentration of solute is present in the left side solution, whereas in the right side solution, some molecules are mixed inside it. Okay, you understand what I am telling you? So here in case of osmosis, I have told you that the solvent concentration determines everything. When there is more amount of solvent, it moves to the less amount of solvent side. I was telling you about the molarity, you have to think about it. These solutions are molar solutions. Okay? Molarity, I have already told you about it. You take some 200 grams of salt. Okay, in case of NaOH, let's have an example. In case of NaOH, its molecular weight is 40. Take 40 grams of NaOH, mix it up in 1 liter of water. How you have to mix? First you have to mix in 200 ml of water and then you have to make it up as a 1 liter solution. Okay, and this is a 1 molar solution too. We are following molarity, not the molality here. And if you take this 1 molar solution, you are placing it here. Let's consider that you have placed here. Here it's with the distilled water, not with any amount of salt. It's there. Where can you see the solvent concentration in high amounts? Whether here or there, to the left side or to the right side. I'm asking about the solvent concentration. Solvent is water. Let me simplify it. Water. Where can you see the high concentration of water? To the left side, isn't it? Not on the right side, because in the right side you have some sugar or salt molecules mixed with it so that it has occupied its place. So more volume and more concentration of water is seen in the left side and not in the right side. In osmosis, the movement takes place from the high solvent concentration side to the low solvent concentration side. You must understand what I am telling you. It's not the solute concentration. Usually when you speak about a solution, we speak about the concentration of the solute. But I am speaking something which is reverse to that. When you have more amount of solvent concentration, the solution becomes dilute. And if you have less amount of solvent concentration, the solution becomes high concentrated solution. Let me give you an example. We are having 2 test tubes. One is with 5 ml of water, another one is with 10 ml of water. In both the test tubes, we are adding salts. In the test tube which is with 10 ml of water, I am adding 1 gram of salt. And in the second test tube which is with 5 ml of water, I am adding 0.5 gram of salt. What is the difference between these 2 test tubes in terms of concentration? Same concentration, that is the right answer. Why? Why do we have reduced the volume, but we have reduced the solute too. Whereas if I am adding 1 gram of salt in both the test tubes, what is the difference between their concentration? That which is having 5 ml of water, they exceeds the concentration. You understand what I am telling you? In both the test tubes we have same amount of solute, whereas the solvent concentration differs. So when I reduce the solvent concentration, the solution becomes very thick. The solution becomes very concentrated. Whereas in case of the solvent, if it is increased in its volume, it dilutes the liquid. Here that happens. Here there is a negligible concentration of sugar. So when it is kept in between a semi-permeable membrane, this is a semi-permeable membrane, not an ordinary membrane. So this is the semi-permeable membrane. If you look at it, it has so many pores between them. So at all the instances, they have the possibility to move the solvent from the left side to the right side. Okay, you understand? So what happens here, to combat that situation, this is a high concentrated liquid and this is a low concentrated liquid. To combat the concentration, that is to substantiate the concentration, they send the water molecules from the left side to the right side. That is from the high solvent concentration side to the low solvent concentrated side. How long they would send this? How long it is possible for them to send? Until they become equal. Until the concentration becomes equal. If the sugar molecules present here becomes negligible, for example you have 1000 liters of water and in the 1000 liters of water you have only 1 teaspoon of sugar inside it. It's negligible. It's not going to impact anymore. So at this concentration they will leave out this osmosis reaction, but it happens only with a semi-permeable membrane, not with any normal membrane that we have. It needs a semi-permeable membrane. Only if it is taken in the presence of a semi-permeable membrane, it would transport. So from this high concentration of the solvent to the low concentration of the solvent, they transport the solvent molecules until they becomes equal. And let me show you other slides too, so that it is possible for you to understand. We have some questions for discussion, but it is not possible for us to have. What is it partially permeable membrane? That is semi-permeable membrane means. It's not going to permit anything as such. It's going to stop the materials, and that is the problem. Let's have this. See, generally a molecule could move from one side alone and not from the other side. Why? There is a concentration barrier here. In the flow of the liquid, if the concentration is different, it moves only from one side, not from the other side. It gets stopped at this point. And if you may be thinking that why can't the liquid from here, it moves in the opposite direction, it won't move. There is a barrier always, and it's generally caused because of this semi-permeable membrane. That is why we need a semi-permeable membrane in between. And the concentration difference, they won't allow the influx of the liquid from the opposite side. The two from the right side of the picture, it's impossible for them to move to the left side of it. Then you are going to fill all these things. Okay, the first one let me fill. The second and third slots you have to fill the answers, because we have seen the subject, we have learned the subject. Now you have to answer these questions. So taking this osmosis into consideration, and in the last class I have explained you about the diffusion too. Osmosis is also a type of diffusion, but it's a special diffusion which is concerned with the solvent concentration. Okay, it's a special type of diffusion, and that is the first answer which I have to give you. How? I have already told you that water is something which is very unique. It can be considered as a solute, it can also be considered as a solvent. When you consider water as a solvent, osmosis happens. When you consider water as a solute, in the plant system, the diffusion happens. Okay, so osmosis is once again a special type of diffusion. What is here? What shall be placed here? Osmosis is the diffusion of solvent or solute? What molecules? Solute or solvent? Solvent molecules is the right answer. From which region? From the region of water molecules, high concentration of water molecules, to the region of low concentration of water molecules across a semi-permeable membrane, and that is the right answer. I hope you have learnt about it. There are a few examples that we have to speak about. Okay, see, this is a blood cell, and this is a cell which is devoid of water. At times when you are starving, or if you don't have adequate amount of water, what happens inside your system? Your system is full of thirst. And the water molecules inside the blood cell, they do move out of the cells, and they create very great need for the water. And when you pour some amount of water, or if you drink some amount of water, when you have thirst, your blood cells, they lose the water. When you drink some amount of water, the blood cells, they regain their original position here. This is what we have seen already. And going further, the net movement, they happens in a very steady state, and the net movement, they increase in the volume. See, the molecules which come to this side, the water molecules which come from the left side to the right side, they are adhered around the surface of the salt molecules, salt or the sugar molecules that we have placed in the right side. They get adhered to that water molecules, and thereby the combination happens. And these are three types of solutions which we have to compare. One is hypotonic solution. What is a hypotonic solution? Tonic refers to the solution, and hypo means low amount of concentration. If you have to speak about concentration, always you have to think about a comparative solution. There is a solution which is standard to be maintained, and to that standard solution, if a solution is less in its concentration, then it is hypotonic. Okay? If it is more in its concentration, it is hypertonic. And if it is same in its concentration, it is isotonic solution. So let's consider two plant cells present adjacent to each other, and these two parenchyma cells, they have to transport water from one cell to the another. The first cell and the second cell, if they are same in the concentration of water, then it is isotonic, or same in the concentration of a solute molecule, it is isotonic. Okay? Or if both of the cells, they differ in the concentration to that of the third cell, it becomes hypotonic and a hypertonics in its solution. What happens if you place a hypotonic solution and a hypertonic solution within the system? But if you take this, the hypotonic solution and the hypotonic solution, and separated it with a semi-permeable membrane, the molecules from the hypotonic solution, they won't move, because the solute molecules, they won't move in case of osmosis. Solvent molecules alone, they move across the membrane, and they increase the height of the tube at one side. See the difference in the second one. Okay? This is the important thing that is happening here. So at time, when time goes by, the water molecules which are present at the left side, they just move to the right side, and the increase in the volume, and this happens. In case of isotonic solution, nothing moves. It remains as such. If you place two isotonic solution here, same in the concentration, if they are same in the concentration, nothing can move from this side or from this side to that side. Nothing moves. Okay, and this is the important thing that is happening. So let me finish this. This is a hypertonic solution, isotonic solution, and a hypotonic solution. See, if you are placing a hypotonic cell into a hypertonic solution medium, then the cell will lose everything, because it is more dilute. Say for example, you are taking a plant cell which is hypotonic in nature, when compared to the standard solution that you are having in the test tube. You are placing that cell into the test tube. What happens then? The water molecules which are present inside the cell, they move out of the cell, and plasmolysis occurs. Plasmo, it means the liquid that is present inside the cell, and lysis means death. All the liquid material that is present inside the cell, they moves out of the system. Okay, when you place a hypertonic cell in a hypotonic solution which is there in the test tube, what happens then? Then the solution from the outside, they move inside the plant cell. The plant cell becomes turgid, it becomes big, at one point it may burst out even. This happens. If you place a cell which is in the same concentration of the liquid that is present in the test tube, nothing moves. Nothing moves from the cell, or nothing moves from the solution to the inside of the cell. This is the actual thing that is happening into it. And let me go back to the party. You had been to a party, many people are there, it's a very big crowd. So you got suffocation, you moved outside. But you really enjoying the party, and you want to be there inside. You want to enjoy yourself with your friends. What do you have to do then? What do you have to do? You have to spend some more amount of energy. Why? You have to resist the condition. Always you have to resist the condition and be there. That is what happening here. Whenever an osmosis happens from the system where it is diffusing, energy inflow needs. You have to spend some amount of energy in your body to sustain there inside that room. And the same thing is happening here. Here also you have to spend some amount of energy, and the process becomes an active process. In case of a diffusion is not an active process, it is a passive process. Here, this becomes an active process and the osmosis happens. Either endocytosis or exocytosis happens. What is endocytosis? Endocytosis means cytosis is the cell and endo means influx of liquid into the cell. Exocytosis means the liquid that is present inside the cell, they moves out at variable concentrations. They do this process as we have seen. So this is the one which is happening. This is the pictorial form which I just wanted to show you. So this is the end. I have also taken this PowerPoint from different sources. I have cited it. You can ask me some questions. Okay. Let me tell you, for that I have to once again go back to the previous slide and speak about it. In case of water purifiers that we have at our home, you might have heard the word RO. What is RO there? It's reverse osmosis. Okay? Reverse osmosis. What is happening inside the reverse osmosis system? I was telling you about the osmosis. In case of osmosis, from the high concentration of the solvent, they move to the low concentration of the solvent area in the presence of a semi-permeable membrane. But all these movement, they are preferred by certain amount of pressure that is operating here. And that pressure is called osmotic pressure. So let me show you here, if I just track back. See, this is the solution. So this is a pure liquid which is placed in a side, and this is the mixed up liquid or the dirty liquid that we have. Let's consider this as a tap water that we get from the municipality, and this is a clean liquid that is there inside the tube. What happens if normal osmosis is the process that should be taken place? Water molecules, pure water molecules, they move to this side. This reduces in the volume and this increases in the volume. But this is done by a small pressure which is operating, which I have narrated, that is called osmotic pressure. So if you place a pressure lid here at the top of this tube, if you are placing a pressure lid, let's see this. If you are placing a pressure lid here and just providing the pressure that is actually operating on the next side, this is a U tube, and some amount of pressure is operating here because of the concentration difference, and water molecules, they move from the left side to the right side, isn't it? So you have to understand that pressure. You have to place a pressure lid here and to stop the operation of this pressure activity. When you are doing this, the molecules, when you are giving the actual pressure that is operating here, the right pressure that is operating here, the movement of the molecules from one side to the another side, even though if it is a concentration barrier, they stops because you have operated with the pressure. And if you are slightly increasing the pressure, what happens here? This is a semi-permeable membrane. The salt molecules or the sugar molecules that are present inside, they cannot move that side. In the semi-permeable membrane, the pore size is very much limited, and so the particles cannot cross from one side to the another. So normally there is a problem for the particles to cross, but for water molecules there is no such problem. They can move that side. So in the presence of the pressure that is operating here, something which is very big to be considered. So this water molecules from this side, they slowly move to that side, they increase in their concentration. Okay, let me show you like this. So the water molecule from this side, they move to that side. The pure water collected, they increases in the concentration. This is the dirty municipal water. The salt molecules, dust particles, whatever impurities that are present here, they remain here. The pure water alone, they crosses the semi-permeable membrane and moves to the next side. And the water collected here, they will be taken into a drum, and it could be used for the purpose. And this is how reverse osmosis operates inside the system. Okay, inside a water purifier, water purifying system, this is the process. It's against the osmosis, but for the industrial purpose, we are operating with the pressure lid. We do this, we provide this pressure externally, and thereby it is possible for us to collect the pure water in one side and the impurities in the other side. We used to discard these impurities by the influx of water, and that is one another different process that we have to study. Hope you have understand. If you have some questions, you can raise. Also, I urge you to open some books and study about the topic, so that it is possible for you to keep it in your mind for a long time. In the next class, we shall have the discussions if you have. Thank you.